Okay, so if you guys remember, we talked about using arrows to represent vector quantities. So let's say if you want to represent a few vectors, and when you draw multiple arrows on the same piece of paper, it's highly recommended that we draw the length of those arrows to some sort of scale. And it doesn't have to be perfect. But relatively speaking, we hope our students to draw longer arrows for vectors with bigger magnitudes. For example, I draw two arrows here, one to the right, the other to the left, right? So they represent a velocity, which is going to the right, and I'm going to put positive 3 meters per second for its value. And you guys remember that the positive sign, which is not omitted, is for the purpose of emphasizing that the direction of the velocity is to the right. Because again, you can see from the direction of the x-axis, right, to the right is positive. Now, I intentionally draw the arrow that represents the velocity that's going to the left with a value of negative 4 meters per second, a little bit longer. You might say, well, the negative 4 is obviously smaller than positive 3, right? How come that you're drawing an arrow a little bit longer? Well, because this negative sign is not representing a negative number here. The negative 4 is the velocity. The negative sign simply represents its direction. So the velocity of the magnitude 4 meters per second is larger than the velocity with a magnitude which is 3 meters per second. So that's why you better draw the arrow a little bit longer so that your reader is not going to be confused. And again, remember that this negative sign only represents a direction. Now, another thing for you to keep in mind is that the vectors don't have to be always going straight to the right or to the left, right? So it's perfectly okay if you end up dealing with vectors in 3 dimensions, right? So like you see here, we have velocity vectors start pointing this way, that way, right? So whenever you want to represent a vector, right, graphically, just go ahead and draw an arrow, right, that's going in the direction you want it, right? And you can label it as whatever, let's say maybe 5 meters per second, right? That's the velocity with a magnitude of 5 meters per second going this way, right? So now let's say, what about another velocity that's going in a different direction, right? I can label it as maybe 8 meters per second, right? As you can see that the direction is obvious when you see the arrow, but I do want to make sure that when my readers see multiple arrows on the same page of a paper, and the long arrow usually represent a velocity or a vector with a bigger magnitude. Right, that's a good practice. Now, what about the plus or minus signs? So please remember that there's no point assigning positive and negative signs to vectors which are not lined up with a particular axis. You see that we did the plus or minus signs for these two velocities since they're either in the same direction as the positive x direction or opposite to the positive x direction, right, to the left. So when the arrows we draw, like those vectors, are pointing in all sorts of directions, right, to the top right, bottom right, right, top left, don't ever bother with plus or minus signs. Okay, so simply put, you only get to take the advantage of plus or minus signs when vector quantities are lined up with a particular coordinate axis.